Thank you ever so much. First of all, my name is Jason Pritchard. I'm the editor of eVTOL Insights, for those who don't know me. And we're really happy to be able to join us all today to talk a bit more about the presentations that we've got Felipe and we've got Peter from Flock that's coming with us as well. We're going to have 15 minutes for each presentation, and then we'll have some questions afterwards as well. So just wanted to let you all know there as well. I'm going to start as well, if that's okay. Peter, I know we spoke at length, Felipe. So Peter, if you're happy to go first in this instance. So Felipe, if I could just ask you just to turn your camera off, and then we'll come back on that as well. That'd be brilliant. And yeah, we can begin if that's okay, Peter. So just here for everyone, Peter, he heads up the sales for Flock's drone insurance business, having recently joined from Sensat, one of the UK's leading drone surveying businesses, and which is now a Flock customer. So Peter scaled the commercial team at Sensat through a Series A and is now doing the same at Flock. Peter never thought he would end up working in insurance, nor did he think it was cool, but he has been proven wrong on both of these fronts and sees InsurTech as an integral part of unlocking the full capabilities of UAV technology that can revolutionize the way we live our lives. And today he'll be speaking about how we can reduce the bottleneck insurance presents for the eVTOL sector. So Peter, with that, really looking forward to your presentation. Over to you.
Thank you very much, Jason. Really appreciate the intro. Let me just share my screen and hopefully we are good to go. So let me share that. And if I then say present. Okay, not sure why you've still got my my bar at the top, but I reckon that is that's good enough. So I'll get going. Lovely to meet you all. Thanks for having me on Jason, and great speaking with those who I had a chance to speak with on the table just beforehand. But for those who I didn't get the chance to introduce myself to, I'm Peter. I head up the sales for Flock's drone and eVTOL business. I'm going to speak today about how risk intelligence can help unlock the full potential of eVTOL technology and help make these incredible vehicles that are emerging and visions for what this is going to look like in the future a reality. Before I jump into all that, please do give us a follow on social media. You'll find us on Twitter at Flock Cover and also on LinkedIn. And also feel free to reach out to me directly. My details are at the end of the presentation. Be more than happy to connect and answer any questions you might have about insurance or about any other subjects. So what am I going to cover today? Well, first of all, I'm going to give you a quick intro to who Flock are, how we go about calculating risk, and ways in which we can work together with the eVTOL industry to help reduce the kind of potential bottleneck that can be insurance. And then I'll finish off by speaking about some really exciting case studies where our customers are already pushing the boundaries of what's possible in the eVTOL space, and how our InsurTech has helped enable that. Awesome. So to kick things off, to give a bit more background on who we are, Flock are the go-to insurer for connected vehicles. So we harness big data and real-time data produced by both drones and commercial fleets on the roads. So we also have a motor product as well. What we're doing with that data is providing fair and transparent insurance for connected vehicles. Whether that's on the ground or in the skies, each customer is being treated on their own individual merits, and as a result of us tying into the connected nature of these vehicles, we're not only able to identify and insure against risk, but we actually also provide insights to help mitigate against risk in the future. So what do we offer in the drone and eVTOL space, which is the area that I'm responsible for? We offer a range of products. It really depends on what your needs are. And also, it depends on what you're doing, whether or not this product would be the right fit. But we offer everything from hourly, daily, through to monthly and annual insurance policies. As mentioned, we do have this usage-based policy as well. This can tie into flight management software like Centric, for example. And this really is rewarding customers for operating in a safe and risk mitigated manner, and also ensuring that you're actually only paying for the flying that you're doing, rather than having a kind of a fixed annual policy. Just to kind of clear the air from the discussion on the table, I think everybody's kind of very much aligned in the community, but there is a lot of terminologies and acronyms bounded around in this space, and sitting across both drone and the eVTOL sector, I'm aware that VTOL and eVTOL is often used when referring to the capabilities of takeoff and landing for drones. And whilst that's very much within my remit and interest as well, but today the focus of my presentation is really going to be on the larger and more complex category, like the vehicle on the right hand side of this slide, that may be deemed air taxis or flying cars, as opposed to drones. Now, the eVTOL industry has a challenge due to the nature of the emerging use cases, and the lack of regulation and lack of historical data. A whole host of new risks that stuff has never been done before in the type of in this space. It mean that it is very difficult to identify and quantify flight risks, particularly for insurers. So what I'm going to speak about today is how we calculate risk and how we seeing ways in which we can kind of make this a reality. So, what risk factors should you be considering, both in terms of planning your operations, planning your scale up, but also about how you are going to present if you are an eVTOL manufacturer or operator, how are you going to present that risk to the insurers to ensure that the risk is being communicated in the best possible manner. At Flock, we think about risk in three specific buckets. So the first being pilot risk. Now, actually, for eVTOL, this breaks in two. One is the kind of risk related to the experience of your pilots. So how many hours of aviation experience have they got? Is that in traditional aviation? Have they been operating maybe larger and more complex drones? It's unlikely if you are a kind of new eVTOL developer that your pilot will have direct experience operating that particular aircraft. Do they have experience operating other similar aircraft? If not, how can you mitigate that by ensuring you have somebody with tons of experience from traditional aviation? The second aspect, unique to eVTOL, is really that actually the vision is that there will be pilots, or there may be a pilot in the aircraft as well. So that's definitely something that also needs to be considered. The second bucket is the asset risk. The technology behind eVTOL aircraft is often very advanced and therefore very of high value. In addition, the larger aircraft can be quite weighty as well, and there is a significant risk if something did go wrong, that an incident would cause damage to both the could cause significant damage to the vehicle itself, and this is a risk that needs to be taken into account. And finally, environmental risk. So this is really everything else that's going on around. So if you're thinking about it from an insurance perspective, this is the third party liability. But if you're thinking about it from an operational perspective, it's where can we operate? If this is test flights that we're planning, what can we do to mitigate the possible risk here? Are we in close proximity to any buildings? Are we in close proximity to any significant infrastructure or groups of people? What can we do in terms of planning here? And if you're looking at kind of scaling up operations, again, it's like looking for the path of least resistance for scaling your operation. So where we've seen some great success is starting in rural areas, for example. Now, this is a huge amount of data to take into consideration, and traditional insurers have often kind of balked at the task or struggled to understand the risk for this new and emerging technology. This is where Flock's risk engine comes in. Flock ingests data from a huge range of third-party and proprietary data sets. So this is real-time data sets, and also fixed data sets like the built environment information coming from Ordnance Survey. We also get like live traffic flows coming in as well. Our risk engine then analyzes all of this information in an aggregated sense and places a risk score 0 to 100 against that particular risk, and this risk score is then used to inform what the insurance premium should be. And this risk score really helps us understand the probability and severity of an incident occurring. So just to give you a quick visual of what that actually looks like. Now, this visual was developed for a drone operation. For those that know London and have got an eagle eye, you might recognize some of the place names. This is a planned VLOS drone flight around King's Cross. What it's actually showing us is the bars are risk. Red is high risk, yellow is lower risk. And this is showing the risk of a drone operation over the course of the day. And the ebb and flow of the bars relates to the time of day. So this is really looking at how risk changes over time in a particular geography, and it's really interesting looking at that. Quite how the impact of commuter times has over the potential risk. So obviously, if we were talking about an eVTOL flight, this risk map would be more of an A to B. And having just launched a product for connected and autonomous motor vehicles, this same model is being used for A to B calculations, which is really fascinating stuff. So I mentioned at the start that there's a potential bottleneck for insurance when it comes to eVTOL. There was a really interesting article that came out a few months ago where Brandon Robinson, CEO of Horizon, was quoted saying that most eVTOL aircraft seeking to become commercially operational will fail to secure insurance at a commercially viable price. So I just wanted to, having had some experience in this space, give a few kind of insights as ways to increase chances in this very new and novel space. So number one, it really is scale down to scale up. So the successes we've seen in the eVTOL market is really looking at producing a scaled down prototype where we've seen risks declined by underwriters, is where the insured is looking, they've developed an aircraft, and they want to go straight in and start doing test flights with the fully scaled up version. Where we've seen some great success is where there's been a scaled down version with prototype and a stepping stone approach to scaling up that operation, with the same components, just getting larger each time, and actually providing feedback and reports and demonstrating the success of those to the insurer. Secondly is time. I would be a very rich man if I got £1 every time we receive an inquiry saying we need insurance next week and we want to fly this completely new aircraft which hasn't never been done before, and we're doing the test flight next Saturday. If we were talking about a drone operation, we very much have an out-of-the-box solution ready to go for that. But actually, when it comes to eVTOL, the nature of the risk is slightly more complex, and it's just really important to factor in enough time to properly be communicating that to an insurer to ensure your best chances of finding insurance, and finally working with that insurer rather than seeing them simply as a supplier, simply as somebody who's going to sign off, actually working in partnership with an insurer all the way through from prototype to your end vision of commercial viability, and actually working with the insurer to provide a roadmap of what can be done to mitigate risk, for example, and actually help make it more of a reality. So a couple of quick use cases. So Flock partnered with a pioneering eVTOL company, VRCO, who are a British business pioneering the development of Neo X craft, which is planned to be a hyper luxury supercar of the skies. This was one where we engaged very early and discussed with them for some time about ways in which they could scale test flights all the way through. And it was Flock's risk intelligence engine which helped improve safety standards over time here. Another business you may well know if you're from the aerospace space is GKN. They're actually developing an eVTOL really for research purposes. So there's, as I understand it, there's not a plan to make this a commercial aircraft. But it was Flock's algorithm and the safety specification details shared by GKN which allowed us to calculate a commercially viable premium here. A business many of you will be familiar with, and it's more on the drones. The example here more on the drone side of eVTOL, but really amazing work that Skyports are doing in kind of what I would say is the other potential blocker of making eVTOL a reality, and that's the infrastructure. We've been supporting them on their medical delivery side, but as you may well know, they're developing a series of vertiports around the country as well. And then one final case study for you, outside of eVTOL entirely, but Flock partnered with Lorenz Technology, who are a Danish manufacturer. They've created an AI link, which basically acts as the pilot. And as far as we know, this is the first time in insurance history that AI was actually named as the pilot on an insurance policy. And I think this is actually really, really exciting for the eVTOL sector as well. I know of some manufacturers who are planning to be completely autonomous from day one. And the fact that we have been able to secure insurance where AI is the pilot rather than an individual, it bodes well for the future of the sector. So I hope that's been useful. That's everything from me today. It looks like I might have gone over as well, so apologies about that. But yeah, any questions now? If you've got time, let me know. Otherwise, there's my details. You can also find me on LinkedIn. Would be great to connect.
Brilliant. Thanks ever so much for that, Peter. Another really fascinating presentation about sort of the need for insurance for this sector as well. We have got a question from Tom, which is a really good question. However, I am very conscious of the timing as well, and I'd hate for us to overrun with Felipe's question. So, Tom, my apologies, but Peter, if that's okay with you, if I can send you the question for you, and I can get the answer to then send on to Tom, just to answer that one up as well. So, Tom, sorry we couldn't answer the question live, but we will get that question answered for you as well. So, Peter, thanks ever so much. Lovely to have you on with us this week, and absolutely really appreciate your time as well. So, if I could just invite Felipe onto the stage, and we can go into the second presentation. Peter, thank you again.
Welcome. Thank you.
Excellent. So, Felipe, thank you very much for joining us for this month as well. So, for those who don't know Felipe, he is the CEO and founder of Varon Vehicles. He's got 18 years of experience in leading-edge military technology and deeply involved with military and civilian unmanned aerial systems as well. His company is leading an urban air mobility ecosystem in Latin America, targeted towards the first implementation in Colombia. So, without giving too much away, Felipe, we know it's been a busy year for you and the rest of the team. So, why don't you tell us a bit more about the work that you're doing as well? Over to you.
Thank you very much, Jason. Great to be here. Thank you for the opportunity to speak to your audience and your guests here. Thank you, Peter, for a great presentation. Insurance is always something that is tremendously important, very often overlooked in the urban air mobility world, but definitely something that we have understood to be a critical part of the operation. So I really share the views that you have laid out today. So with that, I want to give you guys a bit of a brief overview of where it is that we want to go. And I think that the message that I want to give out in doing so is that things are going to be gradual. Urban air mobility is not going to happen overnight. There's a lot of clarity on that. We have to understand that we're not going to have a traffic of flying taxis, if we want to call them that, all of a sudden in a city, in between buildings. But rather that what's going to happen is that we're going to have a very slow implementation. And a lot of that has to do precisely with what Peter was talking about in his presentation. It has to do with the fact that many of the things that we're talking about doing have not been done. And with the fact that many of us have understood that urban air mobility is not about aviation, even though we do integrate aeronautic systems, even though we're talking about aircraft, there's a lot of things, components that have not been done before, that have not been integrated before. So we have to understand not what the cool things are, not what the good things are, but rather, and more importantly, what are the things that we don't know about, where the risks are. And that takes time, a lot of time. There's a lot of discussion about not whether or not we will have pilot-less aircraft in our operation, but rather how long it'll take for us to get there. How many years, and in many cases, including myself, how many decades is that going to take? Because of the complexity of integrating such an operation and making it safe. So I want to share with you a few images here as I speak about what we're doing, about where we want to be at, where it is that we're going, not where we're going to start. That's a different question. So we struggle a lot, and we spend a lot of our time in Varon Vehicles figuring out where we're going to start, how we're going to start, and what makes sense, what is viable economically, what business model structure makes sense for us to allow us to build and integrate all these systems into that working system of systems that I'm going to show you, but that it's safe enough to allow an actual operation, that it's confined enough and in an environment that's controlled enough so that it can actually happen. So we have to differentiate those two things, and that's what I'm inviting you to see things from as I share with you where it is that we are going to be at, where it is that we're planning to achieve being in down the road in some years. So with that, let me just share here a few images to describe what it is that we're doing. So, and I want to start with this. We at Varon Vehicles, we're developing what we call infrastructure networks. And we have defined our infrastructure networks as a collection of our vertiports in a given city or suburb, or city, suburb, and region, but a collection of our vertiports connected to each other via virtual lanes, right? Virtual lanes through which our fleets of aircraft are going to be servicing. So that is an image of what we are integrating, what we're developing with all our ecosystem partners, our industrial partners, and it is in a very real way a system of systems. So I just want to invite you to try to understand the complexity of this, right? And the risks that are involved here, and how many things we need to develop and actually master before we get here, right? So with that, we have three components. As you can see, there's three main components in our infrastructure networks. The first one is the vertiports. Building, designing, and operating our vertiports has been a huge challenge. Second component is the airspace integration architecture. Those virtual lanes that link each of the vertiports in that infrastructure network. And of course, it's the medium through which the aircraft are routed between vertiports, and which maintain a safe operation, a well-orchestrated traffic, and of course, a very reliable and robust operation. And third, but not last, of course, are our fleet of aircraft. That's the three components. So vertiports, airspace integration architecture, and fleet of aircraft. And just like with any airline, we as service providers, transportation service providers, well, we need to have many types of different aircraft. And just like any airline, again, the type of aircraft is chosen depending on the mission. We have three criteria in general that we look at when talking about different types of aircraft, and it's the business case, the location, and the configuration that is required. So those three aspects really dictate which type of aircraft we're going to be using, in which location, and for which business case. And this one same infrastructure network can service different markets. Medical markets, for example, by placing vertiports of the infrastructure network in or at or close to medical sites, like hospitals, for example. It can service logistics customers, placing vertiports of the infrastructure network at warehouses, airports, and moving cargo between those locations. It can also service the tourism industry, in which we can place vertiports at hotel complexes, use the ones at airports, at beaches, islands, and so on, to allow operations such as moving people to and from airports, to and from beaches, islands, and other operations like sightseeing operations or natural park visits. So this same infrastructure networks opens that entire universe of transportation services. So we're working with aircraft OEMs, with a few of them, and our pool keeps growing in terms of how we're going to integrate their aircraft, their product, into our operation, right? They have to integrate into the ecosystem that we're building, and that means an operational integration that goes from everything down from the actual nomenclature, the names that we're using, right? The words for the entire structures in the air that we'll see in just a second here. And of course, down into the actual business model. So there's a full integration of all the components. And the first one I'm addressing here is the aircraft, right? And part of that integration, which is a very interesting challenge, is the operation of the aircrafts themselves. How does the onboard operator actually operate the aircraft? And you can see me using and reusing the word operation, and it's confusing, and we understand that. And for that reason is that we have just now launched the Varon Vehicles Urban Air Mobility Names Challenge. And just here a very short invitation for all of you to visit the Names Challenge, which is a great way for you to be able to propose the new names that we need. And the onboard operator is one of those names challenge that we have opened, and you can propose the new names. We cannot continue to use the term pilot because these are not going to be traditional pilots. Their operation, their training, their tasks, everything is absolutely different. Again, this is really not about traditional aviation. So anyway, you can visit the UAM Names Challenge by just going to varonvehicles.com/names-challenge. varonvehicles.com/names-challenge. Very invited to visit us anytime. So going back to the aircraft here, it's a great challenge to try to understand together with our partners how the operator on board is going to actually be doing the operation and how that cockpit number of systems at the cockpit are going to allow the operator to drive the aircraft through this. The second component, the airspace integration architecture. And this is something that it's really neat in terms of being able to understand not only how it's going to be done and how we envision that to be, doable, but where we're going to start. And again, like I said at the beginning, how we're going to start, in which way that makes it viable, safe, and of course, very robust and very reliable. And I just want to share with you here a bit about that airspace integration architecture. If you can see my mouse here at the image, there's a vertiport right here, just for you to have a sense of scale. One of those aircraft that we just saw is right here, the tip of this cursor. That just to give you a sense of scale of this airspace integration architecture. So this allows for a traffic in one direction, traffic in the opposite direction, separation in altitudes, and of course, as we are doing in Colombia, in Latin America, this calls for segregated airspaces, and that segregated airspace linking our vertiports is that red block, that red outer block that you can notice there, within which we have all the other structures in this architecture. So moving on into the third component is our vertiports, and again, this is where we want to be at, not how we're going to start. Those are two different parts of the same story, like I said at the beginning. But this gives you, I wanted to share with you a bit about the vertiport. There's a lot of our resources and energy that goes into the design, then of course construction and eventual operation of our vertiports. And this is very accurate architecturally and operationally. We answer questions such as, how do you land? Do you face this way or do you face that way? What do you do after you land? Where do you move the aircraft? How do you move it? Is it going to be tugged? Is it going to automatically, on its own energy, going to be moving into the parking slot? What happens next? How do you charge? And when you charge, well, where does that energy come from? And we need to answer two questions on our energy vertical at Varon Vehicles. It's how do we obtain and where do we obtain that energy in an economically viable way, but also in an environmentally friendly manner? Those are two very important questions that we are tackling and that we're very dedicated to for years now, and that's a very interesting part of the design. So what happens inside in the interior of the vertiport, and also what happens right at the outside? How do we integrate to the other modes of transportation? The vertiports cannot happen on their own. We need to be integrated to other modes such as micro-mobility ways or charging stations for ride-hailing companies to be able to attach their operations into the vertiport, right, to allow for drop-off and pickup of passengers and movement all the way from origin to destination, as we provide the in-between transportation of the long run between vertiports. So we need to allow for that integration. And of course, the other part, as I was saying very briefly here, because I'm out of time already, what happens inside the vertiport? How do we manage that operation? What do we need to take into account in the design of the vertiports themselves. That aspect, again, as I was saying, takes a lot of our energy and resources. Well, the operation in terms of the real estate side of it, which is a very, very important part of what we do in design. And well, of course, the integration of all that into the airspace side, which is what happens at the platform, not in a hypothetical world, but in reality. How do we move aircraft? Where do they move from? What happens in each stage of that movement? And again, that's a big part of what we do. So with that, I want to close. I'm very open to any questions. You can do it. I'm very happy to do it here, but because of time, again, I want to be respectful. You can contact me anytime. Just visit varonvehicles.com, or you can contact me on my email, which is varon.felipe@varonvehicles.com. So back to you, Jason. Thank you very much.
No worries at all, Felipe. Thank you ever so much for taking the time to talk to us through some really fascinating stuff, and I'm sure everyone will agree it's some really good work that you're doing in Latin America, and we look forward to hearing more developments in the near future. I know we went on just went over a little bit, which is absolutely fine. I have got two questions in here, so if you're able, Felipe, just to answer them as briefly as you can, and then we'll get back into the networking side of it just to finish as well. And it's a question from that we've got, and it's, how are communications handled in your networks? For example, are they using GSMA, wide area networks, or similar configurations?
Well, I appreciate that question in terms of what I said at the beginning, and I think it was Tom you said. So thank you, Tom, for that. The right up front answer to that is we don't know. There's not a definitive way. There's not a specific manner. This has not been determined yet. There's a lot of questions. There's a lot of proposals. There's a lot of technologies out there. And this still needs to be figured out. And communications is a huge part of it. You may have noticed that in the design that there's a place at each one of these vertiports where we need to have what we call our traffic management system, or our TMS. And it's going to be a sort of a C4 place. So communications play a big role. Data communication, not only voice communication, but also data links are an integral part of that. How are we going to do those data links in a way that it's safe? How are we going to do that data link and those communications in a manner that allow for off-nominal situation management, right? And how do we keep hackers from taking over the aircraft? But at the same time, how do we keep the operation safe in a way that somebody can take control in case it is needed? How do we add layers that are layers for safety, such as geofencing, right? Automatically maintaining the aircraft within those virtual lanes that you notice, those green structures where we don't want the aircraft to be leaving from. But how do we do that in a way that an aircraft that needs landing because of an emergency, right, can do so in a safe manner? So these are all critical questions that nobody has an answer to. There are proposals. There's ways we see that happening. And all these technologies you mentioned come into play right there. But the overall scope is a very, very important thing. Is we don't know. We need to figure those things out, and we need to do it slowly, gradually, with time.
Perfect. Thanks ever so much for that, Felipe. And again, just one final question from Robin Brown. So Robin, thank you very much for that question. Is what are the main problems on vertiports, Felipe? Land availability, capital cost, business model?
Thank you for that one. Yeah, absolutely. It's cost. It's being cost effective. The cash flow part of it. It's so tremendously complicated to model. Vertiports are not airports, definitely not airports, and they're not heliports, definitely not heliports. They're a new animal, and I always say the magic of urban mobility is going to happen at the vertiports. The aircraft, they're very attractive, they're sexy, everybody wants to talk about them. But on their own, they're useless. The vertiports, that's where all the magic's going to happen. And the operation is really complex. Designing for a vertiport is not easy. It's not rocket science either, but it's about the modeling. It's so complex. There's so many questions we need to answer. For example, how do we integrate into other modes? And where the actual vertiport itself, not a vertiport in general, but the vertiport that we're talking about, each one of those particular vertiports, what the location is, what the environment is. Those are questions that that define the vertiport. So that takes us into how do we need to integrate to existing modes of transportation? Is there a metro station nearby, bus rapid systems, or transportation or transit systems? Then everything having to do with the passenger management. Or is it a logistics management? We're not managing passengers on those, we're managing cargo. How do we come about doing that in a way that allows for eVTOLs to have a very efficient operation? So to your question, it's the cash flow part of it, the business model, that making it viable. It's probably perhaps the most difficult.
Perfect. Thanks so much for that, Felipe. Well, that's all the questions, and I'm conscious again of the time as well. So Felipe, Peter, thank you ever so much for taking time to present. I hope everyone has found them very useful. Recordings will be available after the event, but now I'm just going to take us back into the networking, and we've got about just under 20 minutes left of networking before we finish. So Felipe, thank you as always.
Thank you. Great being here.